Hi all, I'll be talking about data pre-processing. First, I have mounted my G drive. This is my datasets path. Uh, this is my dataset. I have 13 columns. We will see one by one following. I have just printed my dataset here. I have 12,174 data points. I think I do have some null values. To check that, I have done this part. And in here, I have taken the not null values count. This gives me the distinct values. I have dropped my null values. You can see that my entries number has been changed. What I have done is that to make my prediction simpler, I have renamed Monday as 1, Tuesday as 2, etc. And I've just printed it here so you can see here. I've done the same for road conditions, weather conditions, road type mapping, light conditions, and also for accident severity. My latitude has some commas, so I have stripped it here. It was in string format because of the commas, so I have changed it into numerical values. I've done the same for time component also. Just I have extracted the hard component and categorized it as morning, noon, evening, and night. And I've just printed it here. Next, we will be talking about feature selection.
So now we are going to see about feature selection. So in this code, it calculates the correlation matrix between various features related to road accidents, which is essential for understanding the relationship between different factors that contribute to the accidents. So in the next code, it trains a random forest classifier to predict accident severity using multiple features, assesses it initial accuracy, and employs permutation importance to determine the most significant features. It subsequently re-evaluates the model's accuracy after selecting the top features, highlighting the impact of the feature selection on predictive performance. In this, before feature selection, the accuracy is 0.83. After feature selection, the accuracy is 0.80. So in the next code uses random forest classifier to predict the target variable using selected features obtained from a previous feature selection step. It then calculates and prints the accuracy which with the selected features, which is approximately 0.85. So the inference which we acquire is feature selection may not be advisable since it slightly reduces accuracy. It's more important to evaluate the trade-off between feature reduction and model performance. Next is accident severity prediction. First is decision tree. The code performs accident severity prediction using decision trees classifier. It loads dataset pre-processes and splits it into testing and training data, and then trains the data classifier, achieving an accuracy of 71%. The code utilizes a random forest classifier to build and evaluate a machine learning model using the specified dataset. It reports model's accuracy and provides a detailed classification report. So next, this code utilizes logistic regression for accident severity prediction for achieving 85% of accuracy rate.
Now we are moving on to deep learning due to the dataset's complexity, potential for improved performance, capacity to capture nonlinear relationships, and flexibility for experimentation with neural network architectures, activation functions, and optimization methods. So this code here computes the skewness and kurtosis to analyze data distribution characteristics. So as you can see here, data do not follow normality. The data's non-normality is evident from significant skewness, indicating skew, and kurtosis differing from the expected value of 3, indicating outliers and heavy tails. The data has been standardized, resulting in a mean close to zero, a standard deviation near 1, as commonly achieved through standardization. Now, data splitting is done. So this code randomly splits the data into training set of 80% and testing set of 20% for machine learning. Next is feature scaling. So standard scalar is used to scale the features. It fits and transforms the training data and transforms the test data accordingly. Accident hotspot identification. K-means clustering is used to identify accident hotspots based on the latitude and longitude data. It loads the dataset, determines number of clusters, fits the K-means model, and visualizes the clusters. The cluster center and cluster sizes provide insights into accident-prone areas. As you can see, these are two clusters formed. So now to predict the road surface conditions, this code helps to predict the road surface conditions based on the contextual features. It calculates the part of the day of the week, and the current date, time, and sets the day, light conditions, speed limit, and road type values. These features uses machine learning models to predict the road surface conditions during different times of the day and days of the week. So this code generates a route map between a specified source and a destination address. Of the source address and the destination address, we get a routemap.html file. We run it in the VS Code. There is a polyline drawn between the source and the destination. So geocode addresses are used to obtain the coordinates. Then we use Open Root Source API to calculate the root. So now this code classifies weather conditions based on the temperature, humidity, wind speed, and weather description. It uses Open Weather Map API to fetch weather data. This code builds a neural network model to predict road surface conditions based on various features. It prepares the data, constructs the model, trains it, and evaluates its performance using a test loss. The aim is to anticipate road conditions, taking into account factors like weather, light, and time of the day. This code utilizes the random forest classifier to create a predictive model. It trains the model on the training data, makes predictions on the test data set, and calculates the model's accuracy. It has achieved an accuracy of approximately 93.14%. So now I'm passing the input features as that I've predicted so far. This code predicts road surface conditions of a list of coordinates used on our model. It prepares input features, scales them, makes predictions, and stores the result in road surface conditions.
We have done predicting the road surface condition between the source and the destination. Now we have to predict the accidents, whether an accident to occur between the source and the destination. So we used an algorithm called long short-term memory in RNN to predict. So now we have used the features latitude, longitude in X and accident severity, which is a target variable in Y. We have created a function called create sequence to create some sequences with a length of 10, where 10 is that each sequence takes 10 data points to train the model. Now we have to develop a model using LSTM. So I've used sequential of which adds layer to the model one by one, and to the output layer a dense of unit 1 is added, and now the model is compiled using Adam optimizer with an loss function of MSE. Now we have to fit the result X sequence and Y labels to the LSTM model using an epochs of 50 and a batch size of 32. Now we start running this. It takes few minutes, so we wait for it. We have trained the model over 50 epochs. At the end of the 50th epoch, we got a loss of 0.1013, which is comparatively lesser and indicates a better model. So now we have to predict the accident hotspots between the source and the destination. So we have already collected the latitudes and longitudes between a source and the destination and predicted the weather conditions and road surface conditions for these latitudes and longitudes, and also some static points like day of week, road type, speed limit, etc. So we add them to the input feature and finally append it to the input features. When the input features is not empty, we convert the input features into an array with floating data points. So then we fit and transform the data using scalar. To predict the model using LSTM, we use a sequence length of 10. And to predict the model, we have to shape as if the LSTM model. So I have shaped the input features for the LSTM model and made predictions and stored it in predicted classes. Now, when I run this file, I could see all data points is 1 except one which is stored as 2. So this is an accident hotspot which is indicating 2. It's a major accident. So I have to mark it in a map. So I use a marker with red color to indicate them in the map, and a pop-up of accident zone go slow. So I've created and stored it in route map with markers.html. So I opened it here, copy and paste in VS Code, and I'm running the file. I could see that my route is mapped between source and the destination with an accident hotspot with my pop-up message between Jayanpuram. So this is our project of predicting the accident hotspots between the source and the destination. Thank you. Now we open our VS Code and paste the copied HTML code, and now we run this. We could see a marked route between the source and our destination, and a red icon which is a accident hotspot, and it mentions to go slow. Between the hotspot, between the source and the destination, Teppakulam and Tripparangundram, we could see Jayanpuram marked as an accident hotspot. This is our project. Thank you.